Hey grade 7s, welcome to your Friday math lesson. So I'm letting you guys know you will not have a lesson posted on Monday because of the holiday, so I will see you guys again on Wednesday. So this is what you're doing. I didn't put, it's the same amount of homework as usual, just because I know you guys you don't get, there's not too many long weekends left in the year. We don't have any more actually left in the year. So I do want you guys to enjoy it. Plus, we're finally supposed to have some decent weather this weekend. So go outside, enjoy the nice weather, especially since, we've had such terrible weather this month so far. So let's hop into it. So we're going to start off with our review as usual, and then we're going to go on to our next section of geometry. So our review, we're going to review basically our different nets. So for example, we have a net that looks like this. What kind of a shape would it create? Well, we know because it has triangles coming out from every side, and there's only one off shape, as in the hexagon, there's only one of them. It must be a pyramid. What kind of pyramid? It's a hexagon-based pyramid because that shape right there is our base. So that's a hexagon-based pyramid. What would our next net look like? So if I have, oh boy, this is not going to be a good drawing. So let's do, I apologized for the drawing right off the bat. I'm not the greatest artist in the world. 3, 4, 5, 6, 7, 8. And then we have another octagon on this side. What kind of a shape would this create? It would be an octagon-based prism. So I'm just going to put it as a short form, octagon-based prism. And there you go. So remember, our pyramids tend to have just the one off shape and a bunch of triangles. Our prisms tend to have a bunch of rectangles and two identical shapes. So you guys have been doing a fantastic job with that. So with that, we're going to go on to our next section, which is we are talking about edges, vertices, and faces. So I'm going to try my best to explain this. It's much easier if I had a 3D shape and actually could show you, but I'm going to try my best with my limited drawing skills. So I'm going to show you with a cube because this is the easiest shape to use at the moment. So we have a cube structure. Now I'm going to do some dotted lines here, and this is going to show you what the cube looks like on the other side. So those are the lines that you can't see on a cube that form it. So we are going to go over edges, vertices, and faces. First of all, let's start with faces. This is the easiest one to recognize because faces are those flat 2D shapes that you see make up a 3D shape. So for example, if I lay out a cube net flat, we know it looks something like this. Obviously much better, but this is what I like. So these 2D shapes, 1, 2, 3, 4, 5, and 6, are called our faces. They're the flat sides of the shape. How many faces would a cube have? The best way to think about a cube is a dice. How many sides does a dice have? It has 6. So a cube has 6 faces. Vertices are the corners. So those little corners that kind of stick out and poke you, those are vertices. So you can see all the vertices I circled. They're where lines meet. So think about where all the lines kind of meet. If I show you a 2D drawing of a cube, where all those kinds of lines meet are our vertices. How many vertices does a cube have? 1, 2, 3, 4, 5, 6, 7, and 8. It has 8 vertices. Edges are our lines. So line, a line here, 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 one here, 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 and here. There's a lot of them. How many does it have? Well, we have to count out those lines. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. There's 12 edges. So I know this is very tough to show you guys. The best way I can think of describing it to you is, remember ever making those 3D structures out of toothpicks and marshmallows, or toothpicks and clay? So you had like a toothpick and you stuck some clay at the end and some end here, and then you joined them together to create shapes. The best way to think about it is those little clay bits or marshmallow, whatever you used, those are your vertices. And the toothpicks themselves were your edges. Now, here's the thing that tends to be a little bit confusing at times. However, I'm going to try to explain this as best as possible. If I have a net and I want to count how many edges there are, couldn't I just count all the lines on the net? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Huh. Is that the same as 12? No, so it couldn't work. So because of this, we can't just use our net to tell us how many edges there are. Because if I have a net and I'm folding it up, some of these edges join to become one. That's why there's more edges on a net than there are on the actual cube itself. The best way I can think to describe it to you guys is I will try to share you guys a website that will let you look at a 3D shape online. So it lets you turn it to have like a 360 kind of rotation. So that's a really good way to look up how many edges and stuff there are on a shape, as well as just looking at the images and trying to count the lines, because a lot of them have those like little dotted lines to see through. So I know this is very tough trying to show you on a computer screen how to do it, but we're going to take it step by step. So today what you're going to end up having for homework is a chart where it gives you a bunch of 3D shapes and you count the amount of edges and vertices and faces it has. So I'm going to show you with a couple shape and count. So I see one triangle right here. There's one triangle that goes behind, 2, 3, 4, and 5 at the bottom. So if I have a net, I know it has a square and a triangle comes out from each edge of that square. So I has 1, 2, 3, 4, 5 faces. There we go. Vertices are the corners. I can see that clearly from my drawing here. So there's one corner up here, 2, 3, 4, and 5. So we have 5 vertices. How many edges? I'm just going to use a different color and we're going to count 1, 2, 3, 4, 5, 6, 7, 8. Has 8 edges. Okay. You're going to start noticing a pattern. So you're going to have, it's going to be 2 charts, one of prisms and one of pyramids. But I'm just going to give you a few helpful reminders on how to tell and what kind of relationship the number of edges, vertices, and faces have. So let's look at a cube. And then we're going to look at a pentagon, prism, And let's look at a hexagon-based prism. We're going to do a quick chart where we have this, 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 and we're going to do the base, vertices, faces, edges. So we're going to try to fill in this chart together. So what does the base of a cube look like? As in, what I mean by that is, for a prism, we know there's two shapes that are identical and the rest are all rectangles. I'm talking about the shapes that are not rectangles. So if you have a pentagon, it's that pentagon based. If it's a hexagon, it's a hexagon base. Thankfully, the name of the base is already there for you. So pentagon based prism, it's a pentagon. Hexagon based prism, it's a hexagon. For a cube, we know it's only made up of squares, so this base has to be a square. How many vertices does a cube have? Remember, we counted, there was 8 vertices. How many faces? Think about the sides of a die. There's 6 faces. And how many edges does it have? It has 12. Let's look at a pentagon-based prism. So, the number of vertices for a pentagon-based prism. I will give you a hint. How many sides are on a pentagon? 1, 2, 3, 4, 5 sides. For prisms, not pyramids, but for prisms, you take the number of sides of your base shape. So a pentagon has 5 sides, that's our base shape. You take that number, 5, and you multiply it by 2 to get the number of vertices. So what is 5 times 2? It is 10. Okay? The number of faces. To get the number of faces, you count how many sides there are to the pentagon, how many sides there are to your base shape, so in this case a pentagon, and you add 2. Okay? Because remember, there is a rectangle for each side of a pentagon-based prism, plus the 2 ends pieces. So I basically just take the number of sides and I add 2. So how many sides? There's 5. 5 plus 2 is 7. So for vertices, number of sides times 2, number of faces is the number of sides times 2. Or sorry, plus 2. Number of sides plus 2, sorry. For edges, this is where it gets a little bit crazy, because for a pentagon, there's 1, 2, 3, 4, 5 sides per pentagon. There's 2 pentagons. And then there's all the rectangles that go in between. So 1, 2, 3, 4, 5. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 15 edges to a pentagon-based prism. For a cube, there is 12. There's a pattern there. How many sides are there to a pentagon? There's 5. And there's 15 edges. To get the number of edges, you take the number of sides of your base shape and you multiply it by 3. So there's 5 sides to a pentagon. I take 5 and I times it by 3. And that will give me the number of edges. Let's see if it works with the cube. 1, 2, 3, 4 sides. 4 times 3, because I use that times 3, equals 12. Is that the same number of edges? Yeah. Let's try applying these rules to a hexagon prism. So our base is a hexagon, which has 6 sides. So it has 6 sides. The number of vertices is the amount of sides times 2. Okay? So 6 times 2 is 12. What about for faces? It is the number of sides plus 2. Number of sides plus 2 equals 8. What about edges? How many edges are there? We have to take the number of sides and times it by 3. So 6 times 3 is equal to 18. And I can tell you right now, if you had a 3D hexagon-based prism in front of you and you counted all the vertices and edges and faces yourself, it would be the same numbers. Okay, so I'm going to quickly go over these rules. Vertices, number of sides times 2. For faces, it's the number of sides plus 2. So faces is plus 2, vertices is times 2. For number of edges, it is the number of sides times 3. Edges is times 3, faces is plus 2, vertices is times 2. And that's the rules for prisms. And that's it. So what I'm going to do is, because this lesson took a little longer than I thought it was going to originally, you're just going to have a chart of prisms. So it's going to have a cube, a rectangular prism, a pentagon-based prism, hexagon prism, all that. You are filling in the chart with the number of vertices, edges, and faces that these shapes would have. Remember your pattern rules. So draw out the base of the shape. So if it's a pentagon-based prism, you draw out a pentagon. If it's a hexagon, you draw out a hexagon. If it's an octagon, you draw an octagon. How many sides does that octagon have? It has 8. Then you apply the rules for vertices, faces, and edges. So vertices, we're multiplying it by 2. Faces, you're adding 2. And edges, you're timesing it by 3. And that's all there is. So that's what you're going to have for the long weekend, is basically a chart where you're filling in the numbers. And that is basically going to be it. So I hope you guys have a fantastic long weekend, and I will see you guys on Wednesday. If you have any questions or anything like that, be sure to email me. I also love hearing from you guys because I know it's very tough not being able to see each other all the time. But thank you guys for being so awesome and so on top of your work. I've been getting some amazing responses. And otherwise, I'll see you guys Wednesday. Have a fantastic long weekend and enjoy the nice weather.